over here miss the first week session, so we would first go over like Gemini API and its basic, and then Gemini Nano, just to have a clear understanding. Okay, so how many of you are like familiar with Android app project and like, any beginners in the house? Okay, you're familiar. Okay, perfect. I'm a beginner. Okay, then I think for like everyone's like me just to make sure like everyone is on the same page, I can just do a brief overview on like how Android app is set up and what are the different components. Um, Nothing additional to confuse you at this point of time, but just the right amount of basics to get you started. So if I switch back to slides, I can show what are the different components. So you take any Android app in Play Store, the entire app can be divided into four types of components: activities, service, content provider, broadcast receiver. Now, for the purposes of this talk, we would just be concentrating on activity, which is nothing but a screen or the part of the app where the user can interact directly in order to perform some sort of operation, like a logging screen, a music player screen, an email conversation screen, a settings page, all of those things. Now, every Android app project is divided into something like this, like the structure is divided into the code files and the build system. Now, the officially supported build system from Google is Gradle, and that is where the lower section of the file, you would see a bunch of Gradle related files. Now, the sole objective of a build system is to link and compile and combine all of your code files into one single asset that is allowed to upload to Play Store. It's like kind of like that end product, the APK or the package that you want to upload it to Play Store so that the user can download and get started. The other relevant information would be some of the things that you entered while creating the project, the minimum SDK, which is version of Android OS, inside which we are placing a call to making screen. And this is more of like displaying the UI value or the actual thing that you want to display to the user. So anytime that you are creating a screen which is written in Kotlin and Jetpack Compose, you would be seeing a preview window over here which says split. And if you do that, let's see. Are there any previews over here? Yeah, there should be. But anyways, I can run the app and we can take a look how it looks like. So in order to run an app, you can always use an actual physical Android device connected to your laptop, or you can create an emulator. So for anyone who does not have an Android app, they can go to Device Manager, click on this plus button, add a new device, select create virtual device, and then you will be seeing a bunch of configurations over here, Pixel 9a, whatever. It doesn't matter which one you select unless like you're selecting something at the bottom of the list that is not supported. So like for now, just select Pixel 9a or Pixel 8a or whatever. Click on next and we'll create a virtual device, which we also call as emulator. Once you have the emulator ready, or you have your phone connected, you can click on this play button over here, it says run app. And then over here in the running devices window, the emulator will show up. But since I have a physical device, I have to manually click on add device and select connected devices. And then you would be seeing an app similar to this. The only difference is in your screen, if you have launched this app, you would not see an additional button saying Nano. It'll just say Go, because that is what is part of the starter API template, which is provided by Google. This button was added additionally for Gemini Nano demonstration purposes. Now, once you have the app running, you can click on Go, and then let's see how much time it takes to respond. I think my Wi-Fi is turned off. Yeah, that's why. Preview cast. Give it another go. So here we have a predefined prompt over here which says provide a recipe for the baked goods in the image. And it takes into consideration the images displayed over here and the text. And it sends all of the information to Gemini API. And then the result looks like pretty much like as you guys interact in ChatGPT or all of those windows. Now, if you're new to Android project and you want to navigate around in the code base, there's a cool feature in Android Studio which makes our lives easy, and that's called Layout Inspector. So that you do not have to manually go through, because the first thing you would be curious about is like where that actual API call is being made when you click on the Go button. So over here on the right side, if you can see, there's a tiny button which says toggle layout inspector. So we want to enable that. And we need to wait for the process to get attached. Once it does, we have to select this another tiny button called toggle deep inspect. And over here, let's select the Go button. Once we do that, over here, you would be seeing a bunch of details along with the name of the file and the line number in which the code is present. So you click on that. Over here on the sidebar, the file opens and it takes you to the exact spot where the Go button is present. So here you see there is a button and then there's a text which says Go, and then we have the function which says on click, which basically takes into consideration the images and the text that is provided. That's the prompt. So over here, I don't know, for some reason the preview over here is not working, but the expectation is the screen which we see actually running over here in the device would also show up in the preview window, but some reason the ID not responding. Okay, now let's take a look at what is the code inside baking view model. So over here, as I told before, there's a shortcut that we can use, Command P, that says send prompt.
Wait, sorry, I have a question. In the deep inspect, how did you get to the underlying code?
Oh, yeah, sure, I can show
I'm
you.
just seeing the like text box.
Okay, so the toggle layout inspector is attached. And then over here, toggle deep inspect. See on the right side?
Yeah. But from there, I see like the button, but how do you see like
The actual file.
the actual file? Yeah.
Okay, so once you click on this button, do you see over here on the bottom pane, if you scroll down, it says baking screen.
Mhm.
.kt, if you click on it, does it open up a file in your ID?
Yeah.
Okay. And then once it opens up, the cursor would be directly on the place where,
I see. I
Yeah.
see. Okay.
so that is where the button code is living. Yep. And then within, inside that, there are like traditional front end framework parameters, which you would expect, like the name of the button, on click, and all of those things. Now, inside on click, we are making a call to the view model, and there's a function named send prompt. Now, for folks who are not familiar with view model, there's a quick refresher on what it is. So for all of the software systems that we build, irrespective of your front-end technology, it needs to adhere to one sort of architectural system. Now, until now, the industrial standard for Android was MVP, Model View Presenter, but Google always advised for modern day apps to follow MVVM, which stands for Model View View Model. In short, model is the set of files that is responsible for storing the data. View is the set of files that displays the data. And view model is more of like handles user input and manages the data. So more of like business logic, the stuff like you want to make or network calls, or like, for example, in our case, we are making the call to the Gemini API SDK within our view model. And baking screen is responsible for displaying all of the UI elements. So for that purposes. Because if you take a look at baking screen, everything is created in Jetpack Compose, and it's pretty self-explanatory. Like if you take a look at the names, like column text, pretty much explains like what is going on in this particular screen. If you are curious, you can always use Layout Inspector to click on these various elements, and it will take you to those corresponding uh, piece of code. Now let's take a look at the baking view model, and then over here we have a send prompt button. We will discuss what this view model scope.launch dispatches.io exactly is in a moment, but let's skip this line for a while and then focus on what is going on inside this block. So we are using a variable called cloud model and then calling generate counter. So if we take a look at this, so this is where we are creating generative model and providing the API key. Something very important to keep in mind is never expose your API key like this way. I just did it just for demo purposes. It makes my life easier. But if you want to include an API key in your production app, you need to follow all of the industry standards encryption. Maybe you have to set up your own intermediate server and then fetch a token based kind of thing, but never expose API key directly in form of a string in your app. But having that said, since this is for demo purposes, I have done it over here because it's easier. If you take a look at what is going on inside generative model, I can do Command B, and it takes me inside the source code. So over here, you would see a bunch of different parameters that we can use to configure the exact model of our Gemini API. So the first parameter is the model name and the API key, and then it takes another set of parameters called the generation config. Now, if you take a look at model name over here, it says Gemini 2.5.flash. So where did I get this information from? Now, for that, we need to go back to AI Studio. Yes, so over here in run settings, you can see a drop down over here which says Gemini 2.5, Pro, Flash, Lite, and all of the models that are available, including Gemma. And each of these has like a pricing tier associated with it, but they also have free API calls per day, like 50 to 100 calls per day. But then after that, you have to switch to a pricing model. So depending upon the models which are available over here in the website, you can provide that exact name in your app, and it will switch to that particular model. Now over here, you would be seeing some additional parameters over here as well. The most important parameter in any AI model is the temperature. Now, for folks who are not familiar with temperature, we can take a look at what the source code says for uh, the Gemini SDK. So if we take a look at generation config, we- in the source code, it says the degree of randomness and token selection typically between 0 and 1, but that's not helpful. So I recently wrote a Medium article related to this. You can follow me on Medium. It's Sagar Das, like my first name and last name. And it was, let's see. Yep. So we use temperature to determine the consistency or the creativity of your particular model. Now, lower the temperature, the more consistent or predictive the responses of your AI model becomes. So if you are dealing with maths problems or like logic-based problems, facts and numbers, it's always advisable to have the temperature very low in your model. Else the model will hallucinate. That's the official term that data scientists use. But if you are dealing with more of like creative aspects of your problem, like writing poems, writing stories, you should always keep your temperature high. We can see that demonstrated in our code itself. So over here, let's add this configuration to our model. So over here, we have got the generative model. And then let's provide a generation config. And then we can, for now, temperature is 1.5. Let's reduce it to, say, 0.2 maybe.
But by default, it's null. So what would happen if there's no config provided?
Oh, that's a good question. Maybe it will switch to a default value. We can try that. That's a very good question. For now, let's do 0.2 and then see running devices. And let's give it a creative task. Let's switch off the layout inspector. By the way, ignore download complete text for now. That is for Gemini Nano, which we'll take a look pretty soon. So let's say I want to ask this model with temperature set to very low to maybe write a short story in 3 lines. And keep in mind, max tokens. Let's remove output tokens for now. Let's just concentrate on temperature. Okay, let's try that again. So our code is taking into consideration the prompt and the images. Right.
You have to rerun the app.
Oh, I just did, yeah. Right. Short story. Okay. Bunch of words. Now let's see if we can increase the temperature and see what's the result look like. Maybe it uses less words, or maybe it will be using more words. So let's increase the temperature to maybe 1.8 F. Then rerun. Then we have the same prompt. Right. So you see how this text looks more lyrical, like it's trying to write a poem, versus like before when the temperature was really low, it was more of like sticking to facts. So this is where, so it all comes down to what type of problem that you are trying to solve in your app. Like for example, I work for Vivint, we deal with security. So we cannot afford being creative when it comes to people's security. So for example, we have got 5 cameras attached throughout your house, like one at the back door, one at front door, one at the kitchen door, one maybe at the front yard, and all of those things. So all of those cameras would be continuously be detecting some kind of motion feed, like when someone shows up at your door, it would be capturing images. And then let's say you have this activity stream as well, which has text, person detected or a dog detected. Now we can have an AI model which would be going through all of those texts and providing us a summary, like how many times a brown colored dog showed up at your doorstep, how many times Amazon driver showed up, how many times a package was delivered at your doorstep. So it all depends upon the type of problem that you are trying to solve in your code. Now, to answer your question, if we do not save any temperature, so by default, let's see, so if I do not provide a config, yeah, the default value for temperature is 0.75. So I guess they're trying to balance. So if you take a look at source code, if you do a command B on generation config, yeah, the default value is 0.75. And then there are other parameters as well, like maximum output tokens, like that limits the type of or the length of response that you would be expecting from your model. Then there are top K or whatever. So they're like more of like mathematics related kind of thing, which I feel like from a front end developer standpoint, it does not really matter much unless like you are trying to provide hyper precise AI experience. But in my experimentation, temperature gets most of the job done because the type of solution that you would be providing in your app would maximum be either like related to a logic, like general logic, like maths or like physics, or like general creative domain, like writing poems or writing stories. It's very unlikely that you are dealing with like probably a niche subject, for example, oceanography, maybe like ocean animals. That's a very niche subject which requires much more detailed expertise. So in those kind of problem domains, you can experiment with manipulating top P, top K. Each of these has a dedicated definition for it. Like top K stands for sum of probabilities, and how many tokens to select amongst those highest probabilities. A bunch of experimentation. Okay, now let's take a look at how we are making calls to the internet, or what is the general way of making network calls or like performing tasks in the background in Android, and then we'll switch over to Gemini Nano. Okay, so let's switch back to the slides, or maybe I can take a look at if there are any questions in the chat. It's my view. Okay, no questions. Cool. Let's go ahead to the slides. Okay. Now, any type of operation that you are performing in the world of software engineering can be classified into a synchronous or an asynchronous operation. A synchronous is pretty much simple as the name suggests. Everything happens one after the other in a sequence or in like everything is in sync. Now, when you create an app or when you launch an app from scratch, it can be Android app or iOS app or any kind of desktop app that you are creating. By default, it gets loaded in just one thread, which we call it as the main thread or the UI thread. So that means like whatever tasks that you are performing in your app. When I say tasks, it could be like displaying all of these individual UI elements or making the network call and all of those things. So all of those individual things are called as a task. All of those would be happening in the main thread if you are going through synchronous operation. The opposite end of the spectrum has asynchronous operation, which we use typically for not blocking the main thread and where we want to execute tasks in concurrency. Now, when I say concurrency, people always get confused between parallel execution and concurrent execution. There is a fine line of difference actually. So before I explain how we are using asynchronous operation in Android, let's take a quick look on what is multi-threading. Yeah, so something to keep in mind is both sync and async operations leverage single thread, but multi-threading is where parallel execution actually happens. Now, when a software engineer says parallel execution, they always refer to the act of executing multiple threads in those actual CPU cores. Like when you buy a CPU, you would be hearing terms like 4-core CPU or 8-core CPU, 16-core CPU. So individual cores are like hardware buckets inside which threads are executed. So when you are using a technique of multi-threading, it actually means parallel execution. But if you are not using multi-threading and you are trying to achieve parallel execution, that is when we call it as concurrent execution or concurrency. Now, for most of the operations that any front-end developer does in Android, all of those can be satisfied using async operation. And that is what we are doing inside a baking view model. So this line over here, view model scope.launch, is part of a suite of programming which we call as coroutines. So if we take a look at the slides.
Wait, so it's asynchronous single thread.
Mhm. Yes.
Can you go back one slide?
Oh, yeah, sure.
The next, what was it for multiple threads? This, one slide before this.
Oh, this one.
Oh, I see. No, it's concurrent is what you meant?
Oh, yeah, yes. I don't think I mentioned, I wrote that in the slide, but I was explaining the difference between parallel execution and concurrent execution. So multi-threading is parallel execution, where we leverage individual CPU cores.
You can have asynchronous or synchronous on parallel threads.
You can, yeah. But there's an overhead associated with each time you are trying to spawn different threads. Now, oftentimes, experienced engineers stay away from multi-threading because it has a lot of responsibility associated to it. You have to associate individual threads with thread ID, the allocated resources, opening and closing the thread at the correct time so that you do not create unnecessary processing overhead on your CPU. Because keep in mind that a cell phone or like an Android phone or an iOS phone does not execute just your app. It executes a bunch of apps in the background. So you do not want to hog up those resources for your app that would cause the operating system to maybe crash or kill other processes in the background and all of those hard to detect things. So that's why, in order to avoid all of those multi-threading issues, it is always recommended. Yeah. So this slide actually lists out what are the pitfalls. It's expensive. Threads are limited. Yes, that's something to keep in mind. You cannot just have like 1,000 threads in your application. Every application has a limited set of threads assigned to it by the operating system. But for most of the tasks that you want to achieve doing in the background or in like async fashion in Android, you can achieve that using coroutines. You can read a detailed set of instructions in the official Kotlin documentation itself. So if you go to Kotlin coroutines, they have a bunch of documentation. Or my favorite is, so this is more of like theoretical aspect. So for folks who are not familiar with this, Google does this thing called as Google Android. What was it called? Study task? No, pathways, learning pathways? No. Learning pathways is for the cloud.
You mean Code Lab?
Code Lab, yes. I blanked out on the name. Thank you. Yeah, so if you do Android Code Labs, you get a bunch of hands-on exercise. Like you can visit all of these individual lessons. And you click on Start, then you do Start Course. Um, yeah, like much more detailed. So they expect you to download a GitHub repository and then try it out on your end and then upload the sample and then they would be providing a batch or something. So as part of Code Labs, they also have one for coroutines, if I remember correctly. Yes. Oh, they archived it. Yeah, why not? Yes, but I think this is still available. This repository was archived here. But you get the general idea. It's more of like a hands-on exercise for an individual topic encapsulated in a code lab. But I digress. So we were talking about coroutines. So essentially, coroutine allows you to execute tasks in a concurrent fashion in one particular thread that is allocated to your app. Now, how do we do that in practice? So we take a scope. Since we are inside view model, we use view model scope.launch. And this is where we decide which particular thread that you want to execute. So the available options for this would be, let's see. So we got dispatches, IO, default, main, unconfined. Now, usually for all of the network operations, the general guidance is always use the IO thread or the input output thread. For process intensive tasks, like for example, let's say you are analyzing an image into like different bitmaps and or performing like custom algorithms. For those cases, always use the default thread. And then there is also advice for like main thread. All of that advice is present in the official documentation. But for our task, we would be using the IO thread. Now, anytime you encapsulate a block of code inside view model scope, it by default executes in a Kotlin coroutine so that it does not block up the main thread. So that was all about the basics of Android and how to get started with Gemini SDK.
I have a question.
Mhm.
So the coroutines are the asynchronous
Yes.
task?
Yeah.
Okay.
So if you take a look at this block of code over here, now what that represents is, now anytime you are, let's see, so anytime you are clicking on Go, so the main thread or the UI thread is responsible for keeping the UI up to date, like what are the operations are happening. But the network related operations making the call to API is being assigned to the IO thread.
So the UI thread is always the main thread?
Yeah. Okay, now let's switch our focus to Gemini Nano. Okay, so earlier I think we discussed on this particular flow chart which Google provided to decide on your use case and whether to decide whether you need the cloud-based SDKs or the on-device Nano solution. Now let's take a look at the official instructions. I can paste that in the channel if anyone is interested. So in this particular page, they provide you some of the necessary prerequisites that is required for installing or testing Gemini Nano. Now, one of those hard restriction is you would need one of the devices that is supported officially supports AR core. Now we can find that list of devices somewhere. I remember seeing it somewhere. List of devices supporting Gemini. Yeah, there we go. So you need a Pixel 8 at least, 9, and then Galaxy S24, Z Flip 6, yeah, Realme, I guess like 10 to 12 devices. So over here, I would be using a Pixel 8. Unfortunately, you cannot use an emulator for Gemini Nano. I mean, you can write the code, but it will not execute. So once you have this device, let's go back over here. Now, in this page, they provide you a sample app. Do not waste your time downloading the sample app. It does not work. I have tested it out because it uses way old solutions. They don't even use Jetpack Compose. They're using XML files, which is pretty surprising to me. Yeah, let me see if anything has updated. No, they're still using XML. So what we would be doing is instead we would be using the project which we created earlier as part of Gemini SDK, and instead be looking at the helper class, which I've created. And I can send this file in the chat in a minute. But let's look at the other prerequisites. So once you have a Pixel device or any other supported device, you need to join the AI Core Experimental Google group. So that's associated with the same ID that you would be using in your actual phone where you log in with Google Play Store. That is how they keep a track of who is accessing their AI Core services. Once you sign up for AI Core, you would be, once you sign up for the AI Core Experimental Google group, you need to sign up for the AI Core testing program. I have already signed up, but it's a very pretty basic form. Now, for people who are curious, we can take a look at what AI Core actually is. There used to be a page, but I think they have removed the page. That's fine. Again, yeah, and like in simple terms, it's just like an actual hardware chip that is embedded within your device that helps you executing those pre-trained models that is bundled with Gemini Nano. Other phones other than Pixel and Samsung or the list of phones do not support that chip. That's why, unfortunately, you cannot use Gemini Nano in order to test it. Now, after you have signed up for the program, you have to go ahead and download AI Core APK in your phone. So I have AI Core already installed. We can verify that from running devices. Let's see, do I have AI Core?
This is on iOS as well.
I'm sorry.
This is on iOS as well. It's only on Android phone.
Just for Android phone.
Okay, fine.
Yeah. I think Apple comes up with their own version of AI kind of chip sometime. I'm not sure. If I go to Play Store, search for, yeah, it's installed. And then the last prerequisite would be update the private compute service APK, another APK. So total there are like 4 requisites.
What was the title of the page? I'm just not in the meeting,
Oh,
so I
okay.
can't see the link.
Gemini Nano experimental here. It's still under experimental because I think on-device machine learning is still a niche topic. Even though like everyone is kind of expecting to have machine learning capabilities built into a device, I don't think much of experimentation has been done with how it actually looks like executing the models in the chip itself. Everyone just executes in the cloud servers. Okay, so once you have all of those things, we would be proceeding ahead with our code. Now, the first step that we need to do is obviously add a dependency to our code. So over here, we can follow the instructions in the page as it is. So we take this AI Edge Core experimentation library and add it to our Gradle module. So I've already added it over here. And once you have added the dependency, you can update the minimum SDK value to 31. Now, this is like a hard requirement from Google. I'm not pretty sure why, but they just don't want you to target like lower versions of Android SDK if you're using Gemini Nano. So it has to be 31. And once you have done that, over here, they explain the same parameters which we discussed a while ago, like temperature, top K, or whatever. And then the expectation is like exactly the way how we configured our cloud-based Gemini SDK model, we would be configuring the same way for Gemini Nano as well. So if you remember, or we can take a look over here as well, a cloud-based generative model takes a model name, API key, and a generation config. The good thing about Gemini Nano is it does not require an API key or a model name. Now, I have created a class file called Gemini Nano Helper. So I would copy and paste this in the chat itself. Anyone who is not in the chat, I can email them later if anyone wants.
Is there a cost associated with Nano?
No, no cost. Because, I mean, if you're already using a premium device, you have already paid for that cost that it actually takes for running it on the AI chip. Yeah, no, that's what you see. Business model. Yeah. For some reason, this is not being added. Let's create this file. Yes.
Did you just write that or is that part of the experimental?
I wrote this file referring to this instruction in the official page.
Okay.
Yeah, like if you take a look at over here, they basically describe like what needs to be done,
Mhm.
but they don't provide a well enough sample app to just download and run it. So I just read the instructions and I created the file. Oh, I cannot share this zip file. That's bad. I can. It's 1,000 characters, right? Yeah, 1,000 characters. Definitely less than 1,000 characters.
You can see it at the bottom, how many you've got.
Yeah, it's like 90 lines or characters. I was comparing
It's 802
lines.
Yeah,
characters.
so
it says.
you split it into
Oh,
like
I
3 or
see.
4 messages, maybe.
Yeah. And I guess I can copy and paste it in 2 sections. Let's copy.
Brings you back to the flip phone days where you'd see like
Yeah,
3 of 4.
seriously.
More than 1,000 characters.
Yeah.
It will take forever. I think I need to find a better way to share this. So probably I would be emailing this file to everyone after this session. That would be making more sense. Okay. But it's pretty much simple. Like we can take a look and folks who are online, it's pretty much the same way how we did for the cloud-based model as well. So all we need is to configure a generative model. The difference is the type of file set you are importing. Now, in the cloud-based model, we are using the library Google AI client.generative AI. But for Nano, all of the files are imported from AI Edge AI Core. But the names of the file are exactly the same. Generative model, and then we use a generation config as well, which is generation config, and it takes a context, temperature, top K, same set of parameters. The only difference is it does not require an API key or a model name. It just comes with one particular model which has been trained for specific tasks like summarization or like looking up for like certain dictionary meanings of the words. And we'll take a look at the responses in a moment. And then the additional thing which we need to do before we get started is actually downloading the model. So over here we have a function. Now they have also explained the same thing in the website itself. Let's see over here. So the first step is you configure a generation config as part of AI core, and then you provide whatever settings you want to provide, and then you do a download config. This particular block of call ensures that you are actually downloading the model into your device. So that's why you do not need Wi-Fi or network calls in order to make those generative AI magic. And then once you do that, once you download the app, you would be sending the prompt the exact same way which we did for cloud-based model as well. So you create a code-written scope, and then within that, you would be calling upon or invoking upon the model, and then call generate content, and then it takes a prompt or a text, and it provides you an output. So let's take a quick look how it looks like. Now it's definitely a little bit slower than the cloud API. Now over here, my app says download complete, but if you execute the same code, it would be first downloading the app, and then it would be making it ready for you to use it. So the downloading part is just one time. You download the model, it lives in your device, it is accessed through AI Core app, which we saw earlier, and that is through which your app would be making the calls to the underlying model. And once you have that, you can create an additional nano button. So for example, over here, I created a second button, nano, you can search for nano over here. There we go. Nano, and then calling a second method called send prompt to nano. And within send prompt to nano, I'm invoking nano helper, which was the code which I showed earlier. Now let's go ahead and turn off the Wi-Fi. And let's put this to the test.
Will you be able to get on the call without Wi-Fi?
I just switched off the Wi-Fi for my device.
Okay, fine.
Yeah. So it doesn't matter if my laptop is connected to Wi-Fi. Now over here, let's see. Now this Gemini Nano is not configured with images yet. It's just text. So let's see. Let's ask a simple question. What is the definition of happiness? Maybe it's a complicated question. We'll find out. Okay. Happiness is a state of well-being that involves blah, 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 and it is working without internet. So that's a win. Now let's see if it is consistent with its responses. Let's keep the question same and let's click on Nano. You see, it goes haywire. And when I click on Nano,
Is it using the LLM pre-trained information here? Okay,
Yes.
fine.
yeah, it's like a very hyper-trained, low-cost, low-size model, which is like 200 MB or less. And then it is just trained for like basic tasks like summarization. And that's why, like, if you ask questions like, what is the definition of happiness, it gets confused, like which response it should be showing. So, general advice from Google is use it for proofreading, summarizing. They have given example of where it is actually being used in production as of now.
That's only text, right?
Yes, just text. So if you see, I think Facebook was using this in WhatsApp keyboard. Saw it somewhere. There's this neat animation. I can't seem to find it anymore. Let's see, Gemini. Nano. Yes, a new foundation for AI on Android. That's where they show. What are some of the use cases that you can use? You can create your own recorder app to summarize meeting audio. That is a very specific use case which Gemini Nano has been trained upon.
So what inputs it can take audio files?
So for audio decryption, you would be using, I think it's called Audio API. So Android provides, I don't remember.
So you're first transcribing and that, I see.
So it's a call for sure. I mean, look like you can
Right,
do it, but
right,
yeah, it's
right,
audio
right.
text
You
and
have to
then, like,
first use the speech. Sneaky.
Yeah, so the API name is speech recognizer for Android. And once you transcribe it, you can use Gemini Nano, feed it to the prompt, and then you can summarize or proofread. Another use case is, I think this is right now in WhatsApp that uses Gemini Nano, and what do they do? Smart reply. So much really predicting. Let's see what the animation does.
I thought this was for building your own apps. How would you inject it into WhatsApp? Like you can't.
I mean, Facebook has included Gemini Nano inside their WhatsApp app. That's what I mean. Yeah. Yeah, but yeah, that's, I think that's pretty much the overview of the use cases of Gemini Nano. But let's take a look at, yeah, yeah, that's pretty much it. I would be sending this file as a zip file to everyone who is attending because this is not included in the sample app. But yeah, that's pretty much it. Yeah, if there are any questions, I'll be over here. But thank you for joining tonight.
I'm gonna go, sorry, I was like in the other room, so I was using my laptop speaker to relay it to the big phone. And I couldn't have the echo messing it all up, so I apologize for that nightmare, but, if you guys don't mind hanging on just 1 second so I can check folks in first, I'm very bad.
So I have a, I guess, kind of a fun question with the Android documentation, Sagar. I don't know, so if you go back to like one of the